Well, hello everybody. It's 5 past, so we'll get going. Welcome and thank you for joining us at this year's University of Plymouth Research Festival. Before we start, I've just briefly been asked to run through a couple of housekeeping points. I'm just trying to move the slide along. Hold on, there we are. And I'm sure you can all read these yourselves, but just so you know, you'll all be on mute and your videos aren't appearing during the presentations. If you do have any technical issues, there's an email address on the screen that you can use to help you resolve those. Please do use the Q&A function, which you can see at the bottom of your screens, I think, to ask questions to the panel. We're going to have a question and answer session towards the end. So, obviously type your questions in as you go, and I'll try and get through them all, or at least as many as we can. You can upvote them, so if someone else has asked a question that you find interesting, if you click on it, it will probably move a bit further to the top of our list, so we might get to it a bit quicker. And also, just so you know, the chat function is available for you to discuss things amongst yourselves, but please don't use that to submit questions for the Q&A session because I can't see it. So I won't see them, I'm afraid. Okay, let's get started. This is the agenda for the day. And I'm going to introduce myself first of all. I'm Chloe Rowland, the project manager for the Cybership Lab, which, as you may be aware, is a £3.2 million Research England, University of Plymouth and industry-funded collaboration project with a mission to increase understanding of maritime cybersecurity attacks, primarily on ships' bridge systems, but also on connected IT and OT infrastructure like smart ports and logistics supply chains. And crucially then, to develop resources to mitigate and provide resilience against these ever-increasing cyber threats. As you can see from the agenda on your screen, during today's session, we're going to hear from the people at the university who've been instrumental in bringing this project into being. Professor Kevin Jones is going to take a comprehensive look at the background and the context within which the Cybership Lab operates. Dr. Kimberly Tam is going to take us through the detail of the types of cyber attack that we're increasingly seeing hit the sector, and she's going to show you what some of our current research actually looks like. Then we'll hear from Kevin Forshaw, whose role focuses on ensuring that we're working in partnership with industry in order to benefit the entire sector. After that, we're going behind the scenes a little bit at the university with a session presented by Jenny Milligan and Susan Ike, who both work within our Research and Innovation Directorate. They're going to explain a bit about the background support and the development process that takes place long before a project like this one comes to the public attention. Finally then, as I mentioned, there'll be an opportunity to ask the team any questions that you might have and to pick the brilliant brains behind this fantastic project. So don't forget to use the Q&A button to ping over your questions as we go. I'm going to start with a short video now, just to set the scene, and then we'll hear from Professor Jones. So sit back, relax, and enjoy. I'm Chloe Rowland, and I'm excited to have the opportunity to show you around our new maritime cybersecurity research, training and development platform. This is where we work hard to protect ships, crews and vital global supply chains. So just how important is this work? Well, to put it quickly into context, it's 95% of everything that we use every day important, because that's the percentage of the world's freight moved via ships. It's that important because we and the economy are very dependent on the container contents and cargo that the world's 60,000 strong shipping fleet moves around the planet day in, day out. The enormous effects of a disruption to this supply chain could be seen in stark reality when the huge container ship Ever Given blocked the Suez Canal. And that's why Research England, the University of Plymouth and crucially our industrial partners have invested more than £3 million in the Cybership Lab's first 3 years. Ships rely on information and operational technology, IT and OT, for navigation, collision avoidance and so on. They rely on these systems to keep perishable or volatile cargoes fresh and safe. Cyber attackers are attracted to essential services and infrastructure technology.
Think fuel pipelines, health services IT systems, and power grids. Cybership Lab is a springboard to help the maritime sector develop cybersecurity resilience, at least on a par with the best prepared financial and technical organisations. Let's take a look. There are two parts to Cybership Lab: the console, where via powerful computers and several large screens, our researchers configure, control, and through penetration testing, discover ships' cyber vulnerabilities so that they can develop mitigation tools. Work in the console is possible because of the unique nature and expertise in the secure equipment room next door that we call the Vault. Everything that happens in the Cybership Lab's console depends on the technology here in the Vault, and as you can see, we're very much in real hardware rather than simulation territory. Industrial Research Assistant and Project Engineer Wes Andrews can tell us more.
Here in the Vault, we have a voyage data recorder, we have main power supply systems, networking equipment, which is actually our Ship 1 network. We have a dedicated monitoring interface, we have Ethernet to serial adapters, an ECDIS console and a dedicated computer system. We also have more networking gear and switches which we can pen test, and we also have this nice research project which demonstrates loss of rudder control. All the systems in the Vault directly link to the console systems in the main lab, which enable the researchers to carry out pen testing and vulnerability analysis and visualize the outcome in real time.
There's no sea view, and we can change bridge technology systems at any time. Those are two of the most obvious differences between a ship at sea's bridge and the setup here in Cybership Lab's console. On these screens, we're seeing outputs and sending benign or malicious inputs to real electronic chart displays, voyage data recorders, and automatic identification systems. We are replicating real-world characteristics and potential vulnerabilities of typical ships. With this unique platform now fully commissioned, the Cybership Lab's research team is accelerating its groundbreaking work to provide actionable knowledge, tools and training to secure ships, crews and the vital supply chains they sustain. We're most effective in discovering and mitigating ships' cyber vulnerabilities when we do it collaboratively with industry. Cybership Lab researchers are focused on delivering actionable research and tools in partnership with ship operators and systems integrators. Thanks for visiting the Cybership Lab and for your interest in our very important mission to secure maritime operations, supply chains, ships and their crews.
There we go. I've stopped sharing my screen now. Hopefully you enjoyed that video. And now we're going to move over to Kevin Jones for his part of the presentation.
Thanks, Chloe. I will now try and push the right buttons in the right order. Okay, so hopefully you're seeing a slide with my name on it. Let me echo my welcome. I'm glad you're interested enough in what we're doing to drop by today. We've got sort of an interesting challenge because looking at people in the attendee list, we have everything from cybersecurity researchers who really want the microscopic detail of what we're doing, down to people who are probably about as far from that as you can get, but still interested in the sector or in what we're doing. So Chloe's video just gave a nice overview of where we are and what we are interested in doing. Over the next little while, we'll try and expand on some of the detail, and I'm sure we'll fail to satisfy most people at some level. So do remember, this is a teaser and you're welcome to talk to us afterwards. So my job here is basically to give you the idea of why we at Plymouth think maritime cyber threats is a big deal. It might be self-evident, but when we started talking about it a few years ago, that certainly wasn't true. A lot of the sector would say, why bother? Why are we interested in? Doesn't affect us. Now, the shipping sector has been interested in threats for a long time, but for most of history, they've involved people coming alongside with a cutlass in their teeth or something equivalent and actually sort of performing piracy or whatever acts it is they want to do in the physical sense. That's really changed. While there is still physical piracy and it's still a real problem in the sector, even the physical events now rely on cyber to make them safer. And what we've certainly seen in recent times, both within the maritime sector and in related sectors, cyber is becoming almost the weapon of choice for a number of criminal, terrorist, and even nation state activities. We've seen in the US in recent times oil pipeline being closed down by ransomware, we're talking about millions of dollars and potentially billions in collateral damage. We've also seen, even more seriously, people using spoofed or fraudulent identification system tracking to almost cause warlike incidents. There was a recent case where a Navy warship and also a warship from the Netherlands was accused of being where it shouldn't be based on evidence presented from AIS in ways that were clearly false. Although actually I can confirm the Navy said the Royal Navy ship was where it said it was, and for good reason. So this is sort of something that's now becoming very real. How real? Well, within recent times, we're seeing a huge increase in the number of cyber attacks in the maritime sector, and it is growing significantly. If we look back historically, there have been a few incidents that actually had negative effects. Port of Barcelona was targeted 5 years ago. The Maersk attack, which most people are familiar with, was not a sector-specific attack. It was collateral damage coming out of political and military activity in another part of the world, but it had significant economic effect on the company involved, and actually did result in a, if you excuse the pun, a sea change in the way the industry was looking at cyber. Moving forward to where we are now, in relatively recent history, certainly within the last year or so, all of the big four shipping lines have been attacked in some way in the cyberspace. Most commonly these days, ransomware targeted things on board the vessel to make basically a profitable industry out of holding the shipping industry to ransom. As you'll have gathered from Chloe's assessment of the overall market, there is a lot of money within this sector. So being able to target in a way that you make money out of it is actually very profitable. So ransomware for the sector is now becoming quite common. We also know that for other reasons, not just economic reasons, there are bad actors who'd be very interested in targeting the shipping sector. A very large percentage of goods throughout the world, and certainly within the UK, a huge percentage of goods are moved by ship. If that supply line is disrupted, we can see that it's not very long before there's significant national impact. We recently saw an event where a ship blocked the Suez Canal. In 3 days, there were on the order of tens of billions of dollars loss in productivity and economic damage. And that was accidental. As the sector develops, there'll become more and more deliberate attacks. Why do I say that? Well, if you look at the maritime infrastructure, it's pretty complicated. You have ships, you have ports, you have manifest systems, you have cargo handlers, you have people. It's a very large system of systems. And any system that complicated has a very significant attack surface the malicious actors can take advantage of. And we're now seeing that they will. And it's going to get worse. I mentioned part of the issue was that we have all of these different parts of the sector. Each of them are getting more complicated. On board vessels, there are more and more electronic channels used for everything from communication, sensors, controls. As individuals interacting with the sector, whether that's as crew or as passengers, we are carrying more devices and they all interact. And the Internet of Things, being everything connected to everything else, just basically ups the number of possibilities for harm from our point of view. Okay, so that's kind of, oh dear, isn't the world terrible? Shouldn't somebody somewhere do something about it? So we're actually some of the people who are being those someones and trying to do something about it. One of the things I do at the university is lead the Maritime Cyber Threats Research Group. Not surprisingly, I claim this is an interesting group. I think there's evidence to back it up. As far as I'm aware, it is probably the largest group of its kind that you'll find anywhere. In particular, the diversity of backgrounds that we have within the group, ranging from genuine cyber geeks right through to people interested in AI and application of AI, out to business logistics, psychology, policy, and even history. All of those things come together within the group to give many different perspectives on what really is a global and genuinely multidisciplinary problem. There are many things in the world these days that are very hard to solve with just a single point of view. And even transdisciplinarity, where you transcend the pieces into a greater whole, is definitely necessary to look at some of these things. And we think that cyber in the maritime space is very much one of those because of the reach that it has and the impact that it has across so many other sectors. So we think that we're actually in a unique position to look at both problems and solutions to vessels, ports, operators, and all of the security and economic implications of that. A couple of things that we bring to the picture that are now reasonably well developed are different ways of looking at risk within the sector, trying to make it both accurate, quantified, but also understandable and meaningful to the end users. Sometimes when people working in this space, they communicate very well with the aforementioned cyber geeks, but do a pretty poor job of explaining to people why it is a relevant problem and what an appropriate solution is. Part of the way we're looking to contribute to the solutions are very much the cyber ship lab that we're talking about today, where we are looking at presenting real world issues and building real world solutions to those issues. So usually about this point, somebody says, well, isn't cyber kind of a done deal? Haven't we been doing it forever and don't we know all the solutions? I'm prepared to categorically say no. IT and cyber, very well studied, very well developed solutions in a lot of the space. Even production systems, things like SCADA systems, have had a fair amount of attention. And a lot of people have said, well, aren't ships just another instance of a SCADA system, just like a factory or something else? My answer to that is definitely no. There are very few factories that move from one country to another, change radically the people and behaviors working with them, and actually have to move through some of the most dangerous parts of the world to get to where they're going. So there are a large range of vessels within the fleet, ranging from very low people involved, bulk carriers and so on, right through to large cruise liners, which have thousands of people on board. The systems supporting those ships are very different. The locations that they go through to get to where they're going are very different. That means the people interested in doing bad things are very different. They also have different levels of resources. So, like it or not, if Russia or China decide that they really, really, really need to compromise the system, they probably will. But the average ferry running between the UK and France is unlikely to attract that level of attention, and therefore probably don't need to spend the enormous budget to militarily harden their systems. So it's getting that risk profile right, and getting it right in a dynamic way, because the circumstances of operation, the cargo, the crew, the route, all make a big difference. And a lot of this will also be enhanced as people get more and more interested in developing ship technology for efficiency, better routing, better use of energy on board, more technology. From our point of view, more vulnerabilities. So how do we kind of solve this problem? Well, as I hinted at, we want to look at the real problem and try and come up with real solutions. And that's what the Cyber Ship Lab is all about. The lab is deliberately not a software and simulation environment. Yes, we do look at software and we're interested in vulnerabilities of software, but also beyond that, real physical hardware has different properties to any simulation, and that's what we look at. The software and hardware also carry information that is useful in different ways. So our aim is to try and come up with protections for the sector across this complete spectrum of devices and programs of interest. We can configure the lab in a variety of ways, ranging from beyond state of the art, working with manufacturers to look at next generation technology, right through to the oldest piece of kit that might be the biggest vulnerability in any system if it's still there. And we want to be able to configure that according to profile and in a very easy manner, so it's easy to compare old with new, changing one device with another. We're interested in both fundamental research. We are an academic institution. We want to produce really good papers, but also being practically useful, working with partners to solve the problems they're actually looking at. So what will come out of that? Certainly increased knowledge, but also tools that can realistically be used to help protect the sector. Lab's made up of two pieces. Chloe already described them and showed them in a video, so I won't dwell here, but there's front of house, the console, where we have the tools and the screens, the visualization software, the attacking and pen testing software that allows us to do what we do in a lab. Now notice this doesn't look like a ship, it's not supposed to. This is an environment for experimentation. It's a laboratory. It's where we look at things and poke at things. We do have a ship simulator around the corner, and we'll talk about that in a minute. The other side of the wall, we have kit. The more kit we have, the better we can configure a system to be exactly what it is we want to test for the people we're working with. So quick hint, if anybody on the call has equipment that they'd like us to look at, we're more than happy to do that. And again, despite being a test environment and using simulation for some aspects of things like routing and inputs, this is real hardware, ideally as close as possible to the way it's connected and deployed on a real bridge. We've got some other projects going on within the group that I'll just quickly pass through. The first one, MACRA, Horizon 2020 sponsored project called CyberMar, is interested in risk assessment. We have developed a unique approach to risk assessment, which when I'm wearing my academic hat, I call a dynamic, multidimensional, highly parametric risk assessment model. But when I'm talking to people in the maritime sector, I show them nice little graphs like on the right-hand side of the screen, which makes it clear what they should be worried about in their circumstance at this point in time. MACRA has been quite successful within the industry at the moment, and I can genuinely say award-winning, since the paper on which this is based won the Lloyd Science of Risk Prize this year. So we're definitely in the right direction for both scientific work and making it useful to people. I mentioned CyberMar earlier. This is a project that Plymouth is a UK partner in. It's a large European project with 13 partners across Europe, both academic and industrial. The aim is to try and increase awareness within the sector and the supply chain about cyber risk, using simulation, using appropriate risk models, appropriate analysis to genuinely understand what the sector needs to be concerned with. And we're a key partner in that. Plymouth's in a unique place in this sector. The Plymouth ecosystem has a number of pieces that you just won't find anywhere else. For all of our interested partners, we can provide the Cyber Ship Lab as somewhere to basically do a threat exploration of the systems they're concerned with. Given that understanding, we can produce a meaningful and comprehensive risk report out of a MACRA system. Building on that, we can go across to a cyber range and craft malware that can deliberately expose a particular scenario that we're now concerned with. We can take it back to the ship lab, prove that it actually works on real hardware. And then we can take that scenario, get a real crew out of one of our partners, put them in a full bridge simulator and show them how this would play out in reality. There is nothing like watching people change from, yeah, but could that really happen, to, oh dear, that did just happen to us and it was our crew. We can also take it out to the real world with autonomous drones and with the capability within Plymouth of the Smart Sound to operate with a highly instrumented part of the ocean where autonomy and remote control is very possible. And again, the bottom of this diagram is our partners. These are people we want to provide solutions to. And that's kind of what we're interested in doing. Quick run through the things we're interested in. Cyber attacks are happening, they're not being noticed. We want to both protect systems and collect data to make it more clear what is going on. We're looking at how can we investigate attacks and how can we use advanced technology, including AI-based technology, to develop better tools for both intrusion in an attack sense and intrusion in detection sense. And then ultimately, we want this to feed into regulator and insurance agencies, which will change normal standards of operation within the sector. It's going to get worse. There's no doubt about that. We're just seeing more and more technology coming into the sector. And when we move beyond ships into smart ports, even smart cities, the Internet of Things, autonomy, this is going to be a very interesting sector for a number of years to come. And we're very happy to be on the leading edge of that and intend to continue to develop those capabilities. Having set that scene, let me now pass over to Dr. Kimberly Tam, who'll give a quick run through some of the actual scenarios we're playing out to give you a flavor of what it is we do. So Kimberly, over to you.
Thanks, Kevin. Share my screen now. Hopefully that's good. So as mentioned, I'll walk through a couple of scenarios. Sorry, I'm gonna just, oh, okay. We'll probably have time for one or two. We have about 5 available, but we'll just kind of run through a couple. So the first one that we wanted to show was a man-in-the-middle attack. So this is a fairly standard type of attack on systems where if you have two and they talk to each other, an adversary basically just jumps into the middle and is either listening in onto packets, so kind of just listening in, seeing what's happened, or even manipulating these messages. And that can have some more serious consequences. So we wanted to look at that in more detail. One of the interesting things we get to do with this lab is because we have a number of systems set up with a lot of different connections, we get to kind of pick and choose at which points we want to try and launch a man-in-the-middle attack and see if it can be done, and if it can be achieved, what can we actually do with this access. So especially things like data poisoning to change how certain systems work or the data being displayed to people. Those are all things we can do with a man-in-the-middle attack. So in this first demo, we have a couple of components involved. So we have some off-the-shelf serial to IP converters. Since there is a number of systems that talk in serial data or Ethernet, and we need to kind of bridge that gap on a ship. We use a lot of GPS data. Navigation systems are a kind of a key system that people have a lot of concern about, so we definitely look at that. In this case, we look at NMEA 0183. Not to get too much into detail, but there are several different protocols that these systems can talk to. And as we are working with real systems, we can be accurate down to the wire and to the packets going across it. So in this particular case, because of the systems we have and because of the ship that these systems are being configured to look like, we're doing the older version of the NMEA protocol. So here we can start to modify messages and send false packets, and this leads to misinformation on another navigation system called an ECDIS, which changes how the kind of screen looks like. So here's a quick example of what an NMEA message looks like for this version, and some of the things you're interested in are these. So these are just kind of the packets you would see on the wire, particularly going, let me pull up a pen. Here where we're doing our man-in-the-middle attack. So there's a couple of components involved, which is interesting from the security point of view, because it's not just, again, two systems and one attacker. But we can have accurate messages coming from the GPS receiver and having an accurate serial converter and routers. And accurate wiring. The only issue is since this lab is sitting in one location and ships move, we do need to add a little bit of simulation to be able to just essentially drive the systems. But most of it is real hardware. Some of these have slid over a bit, so apologies for that, but in order to decode the messages, there's certain formats that are defined by NMEA. And when we know that format, we can then start to alter things. So if you're a man in the middle, you can start playing with timestamps, in this case, latitude and longitude, which can cause some havoc if done in the right way. In this demo, one of the things we first tried to modify was something called speed over ground. And one of the fun things with that is it will, one second. Is it playing? Yeah, okay. So here we have Linux, which is our pen testing station, and it is watching the packets as the man in the middle, so watching the packets in transit. This data then gets sent to the bridge, and this is what the crew on the bridge would see. And we have the attacker watching the stream, and when it finds a speed over ground value of 4, it replaces it with 50. So that is the origin of the data, and where it ends up is different because of the man in the middle attack. So this is actually relatively basic since we are statically looking for one value and replacing it with another. Now that we know that it's possible, we can start looking at more delicate and interesting live versions. And in addition to that, we're also very interested in how do we visualize this in a way that people can understand what's going on. So in addition to the pen testing tests we have, we're also working on ways to better visualize this. So instead of the bridge view, which would make sense to crew but not to others, we are developing visualization software. So in this case, you can easily see the data going from the GNSS to the ACTIS, which is the display we saw earlier. And here we have where we can drop a man in the middle attack. So in a moment, that will go red when the attack gets started. And then, oh, there it is. So the man in the middle has been initialized. And you can see in this case, instead of affecting the speed over ground, we are affecting the rudder. And you can see the white ship is the intended route, so what it was supposed to be without an attack. And at the point of the attack, you can see the red ship, which is where it is after the rudder angle has been changed. So as with everything, the hardware is being developed, the pen testing is being developed, but also these visual aids are being developed. And some of the things that is currently being implemented is having 3D views of the ships, better network diagrams. So this is fairly basic, but we're hoping to be able to drag over, click, and control how these networks are set up. And also, as we have more configurations available, how to enable and disable different boxes in this wider network view. In addition, better network packet analysis and visualization for people interested in networking. So as I mentioned, in the future, we have a couple of things we're interested in doing with this particular demo. especially kind of editing contents on the fly, so real-time changes and more fine-grained changes, so not just a static, if you see a 4, change it to 50, and putting kind of more logic into the attack. As I mentioned, this is in one point of the network, so we did it between, think of the Ectus and the serial converter. But as you saw, the whole ship has many nodes and connections, so looking for other places to launch a man-in-the-middle attack is of interest. And of course, we've only seen the change in speed over ground and a change in rudder. But there are a lot of other things in NMEA messages that can be manipulated, and we're interested in seeing how that could affect human-in-the-loop decisions. So if the change data is going to the bridge, how can that affect people? But also see how manipulated it can affect machine-based decisions. So as we go into more autonomy, would autonomous AI be smart enough to detect malicious information? And what would it do with it? Would it ignore it? Would it try and fix it? What would it do? A couple of one theme that you may see a couple of times in our demos, as we develop more attacks, we're starting to see that, the alarm systems in a ship are very good for things like fire, collision, and things like that. But there's not a lot of alarms or ways to notify people of a cyber attack. So one of the things we're looking at as we do more of this pen testing and things is how do we communicate this again to the people? And lastly, I just wanted to mention, we saw the effect of changing a rudder angle or changing the speed over ground. Can we achieve the same effect, but looking at different systems? So exploring the interconnectivity between all these systems, which is something that I believe is fairly unique to our lab setup, because we really are looking at that big system of systems picture. So I have a couple more minutes, so let's do the second demo. So in a similar way to the man-in-the-middle attack, being able to attack the rudder, we tried to find a place where we can, again, same outcome, but different point of attack. So in this demo, we tried to go a lot closer to the mechanisms, so down at the rudder level, and less at the bridge level. So it's an interesting way of trying to see if we could do a same attack, but closer to the physical mechanisms. So you guys actually saw a quick view of the rudder. Hopefully that's not too loud. I don't know if you can hear that. I can't seem to mute it right now. That's okay. So we've figured out, or we've looked into the configuration from bridge to the steering gear and been able to find all the pieces. No video. Good. Okay. It's not the most pleasant of sounds, so that's good. So we have all these several components from the bridge to the steering gear room, and we can accommodate for different NMEA formats, and also it will adjust to the size of the ship that we tell it is, because that changes the rate of change for the angle. This is the rudder. You can also see a peek at the thruster below it. We're actually probably going to add 2 more thrusters so we can have 1 in the front, 2 in the back. So that will probably be adjusted as well. Plenty of things like angle sensors, and again, several modes of communication, not just NMEA 0183, which we talked about earlier. We're going to be connecting it to the ship simulators, which should be pretty interesting. because then we can see what it would look like in the port or in the middle of the sea, and then see the physical rudder actions that would be a part of that. Not only that, as soon as we implement the attack, you can see on the screen the ships start to drift, or what they think they should be seeing versus what is actually happening, and to help visualize and demonstrate that attack being useful. So unlike the previous example, this one alters the physical movement, so there's less bridge visuals in the digital sense. And we are crossing this over with the EU project mentioned earlier a little bit. In that project, we are working with the Port of Valencia. So we are combining the physical rudder, the cyber attacks, but also our ship simulators to kind of understand if we could impact the rudder in a certain route, how would that affect the port? So could we block ships going in? What would be the effect of that? Because we can talk to the port directly about throughputs and repair times. So trying to get that larger picture on what these attacks could actually result in, and how they could affect the supply chain. So I won't go over these other demos. We have some interesting work going on with AIS and spoofing ships. So lots of interesting going on with AIS right now. The only thing I wanted to mention was the future work aspect. So the example with the Navy ships that Kevin mentioned earlier, and things like this article on AIS spoofing used for not so great activity. How can we use the lab to better understand how these attacks are happening? How can we stop them? So kind of detection and mitigation, especially as these things get more complicated and sophisticated. Again, this leads back into smart alarms. So being able to intelligently understand what the urgency is, who needs to know, and what the best solutions could be. Again, something we did with the autopilot, which has some similar outputs, but again, targeting a different system. So that's all the time I have for demos. Again, if you're interested in knowing more, let us know, or coming down for live demos or to see some of the new things we're doing. You know where we are, hopefully. And with that, I will pass it to the other Kevin Forshaw, for the next bit.
Thank you for that, Kimberly. Just give me a second so I can sort my screen out. Right, so hopefully that's coming through okay. Can everyone see that? Yeah, I think we're there. Okay, so yes, so my name's Kevin Forshaw. I'm Director of Industrial and Strategic Partnerships at the Faculty of Science and Engineering. And very pleased to be here today just to talk about really why we're working so extensively with industry and other maritime stakeholders on this project. So as a university, you'll be fully aware that we teach, we do education, but we also do a lot of research. And in the university context, we do a lot of research at a very low TRL level. So TRL being technology readiness level, that's a scale that runs from 1 to 9. So 1 is like the germ of an idea, 9 is an actual completed product that's been tested and is actually used in a real life application. So we at the university do a lot of low TRL research. This is sort of 1 to 3. And typically this is using research council funding, but increasingly we're engaging with industry, both large, small, local, international, so that we can do collaborative research with them so that we can develop the new products and services of the future. And in terms of how we do that with companies, well, we can do contract research. So this is research that needs to be done now, so they can access our labs and facilities to do some very sort of short-term commercial testing for them. But also we can do consultancy, we can have sponsored PhDs. And this is really applying our leading expertise and our leading facilities, laboratories to resolve specific issues affecting their company business. But also we increasingly partner with them for collaborative research. And there's been a big shift in funding in the UK over the last 8 years. So we had the industrial strategy, which is now morphing into the innovation strategy later this year. But this provided a lot of funding for industrially led collaborative research. And then in the European field, we've had Horizon 2020 as a framework program for collaborative research, which is what funded CyberMar, the project was mentioned earlier. And we're now moving into Horizon Europe. And this is European funding that supports very large consortia projects. So typically 20 different organizations working together, where the research base, including universities like our own, engage with these companies to apply their leading thinking to inform the solutions of tomorrow. So coming back to that low TRL research, and really what we're doing at the university is we're looking at the basic principle development. So a new idea, a new concept, it could be a new material or radical new thinking. And that's really what we draw Research Council down to do. But then we want to engage with industrial partners. So if we're working at TRL 1 to 3, we want to work with industrial partners from TRL 3 up to about 7. So this is taking that idea and further developing that idea with them, producing prototypes, producing proof of concept, which we can then test in the lab. And then when industry have got a proposition that is sufficiently been de-risked, they will then provide the commercial investment to take that forward to a commercial product, a new product or new system. So by partnering with the university, the companies have access to a lot of early stage thinking that can then be commercialized. And really it's world leading expertise in facilities like we have the University of Plymouth that allow them to drive their R&D to create those new products and services of tomorrow. But it's not just research, and really what we want to do at the university and what we're doing increasingly around the Cyber Ship Lab is really to develop those long-term strategic partnerships with these companies. And as I say, we work extensively, work with over 3,000 companies a year, and these are small, large, local and multinational companies. But it's that ongoing research and development support that I've already mentioned, and that nearer term, more commercial testing that we can use the Cyber Ship Lab for. So we can actually test their products and systems. But also all companies are looking to have the brightest graduates working in their companies going forward. So we also want to partner with companies and get them engaged in guest lectures here, get them engaged with student projects so that our graduates, when they leave the university, can then go and work in those companies. And also shaping infrastructure investment. The University of Plymouth works extensively with local partners, so Plymouth City Council, Heart of the South LEP. And we're always working with groups of companies to shape further infrastructure investment needed in the city. And I guess Cyber Ship Lab is a classic example of that. We are working extensively with other Plymouth partners at the moment to push for more of a smart port lab. So further facilities that will allow Plymouth to do that vital proving ground of a mix of autonomous ships and human piloted ships coming into increasingly smart port environments, where all that cargo will be autonomously unloaded onto road and rail as we go forward. So by working with us, you can help shape what further infrastructure is needed to allow these new products and services of tomorrow to be developed. So coming back to Cyber Ship Lab specifically, and here we're working with shipbuilders and shipping operators. So in terms of companies making equipment that go on board ship, they can engage with us at the Cyber Ship Lab to ensure that their systems are more ruggedized, less prone to cyber incident as we go forward. In terms of shipping operators and port infrastructure, what we're doing is, improving the safety, improving the security of their operations. Classifications, we're working with 2 of the leading classifications, including Lloyd's Register, who are a formal partner, but we're working with them to shape the further future standards that are going to safeguard cyber attacks on shipping as we go forward. Insurers, currently there is no provision for risk assessment on maritime cyber insurance, and there is very little provision for taking into account any mitigation actions that any specific operator may have already undertaken. So we're increasingly working with the insurance sector so that we can help inform them of the severity of risk that might be applicable to a specific ship or a specific route. IMO, the International Maritime Organization, brought out regulations last year mandating cyber risk assessment. These are now being translated into various countries around the world. And increasingly, we want to be working with IMO to shape those future policy standards of the future. Cyber Ship Lab was very, very much a joint effort. So I worked extensively with the academic presenters on the call today. So Professor Kevin Jones and also Kimberly Tam. So they were the brains of the project. We're going to hear from colleagues in our research and innovation area in a minute, and they were the ones who spotted the call, and they were the ones who actually presented the bid, actually wrote the bid. In terms of my role in the project, so I reached out to many companies to encourage them to join us on this mission, which wasn't difficult to do. Many shipping operators were telling us it's exactly the right approach. And some of those companies mentioned there on this slide have been working with us extensively to either provide equipment in the lab or help us shape the lab. So it's very much a joint effort. And it was great that we won the funding, and that funding then allowed us to employ Chloe as project manager going forward. And it will be a very exciting project as it develops. So looking to the future, we want to engage with more and more companies, as was mentioned earlier. We already have a lot of kit in the lab, which is quite a feat because we had to build the lab last year. And the last 18 months has been quite a challenging time to build any new facility. So we do have a lot of equipment. We'd welcome further equipment, whether it's new, whether it's secondhand. The more equipment we can get in that lab, the more we can accurately represent any configuration on any chosen ship we want to look at. We want to work with both commercial shipping and also Royal Navy and other navies around the world. You know, it's both defense and commercial shipping. And we want to work with an extensive community. Autonomy has already been mentioned. So we're moving towards a future of having some autonomous ships. How long this is going to take, estimates vary between 10 and 20 years, but existing ships are becoming increasingly autonomous. And we have a wide variety of small data collection autonomous platforms already being operated within ocean environments to collect data. So working with these other stakeholders and moving to a future of a smart ports environment, has already been mentioned, is also a key strategic imperative for us. So the Cyber Ship Lab is very much an internationally recognized key facility, a very, very important facility that also fits into a much wider agenda. So largely because of resource scarcity, there is rapid growth in the ocean economy. The land base cannot sustain the rapidly growing global population. And we are now looking to exploit the ocean environment for energy, offshore renewable energy, food, massive increases in aquaculture predicted, in fact, 10-fold growth in aquaculture in the UK alone over the next 10 years, as we now eat more farmed fish than we do line caught fish. Also, we're looking at gathering minerals off the seabed, so massive increases in that global ocean economy. And as you get an increase in the use of the ocean economy, you're obviously going to get more and more specialist supporting vessels to go and support these various markets. So a far more crowded ocean environment with traditional human piloted vessels and an increasing number of autonomous vessels. We've been very lucky recently. We won some further funding to support Cornish floating wind extension of the Cornish coast. This is going to allow us to get another ship's bridge simulator. This is a full mission class 3 DP simulator. And this, working with Cyber Ship Lab, will allow us to look at future maritime operations and make sure that they're cyber secure and they're safe for all the operators included in them. And also increasingly as we go forward, again, coming back to the context and the key strengths of the University of Plymouth, any future exploitation of that ocean environment has to genuinely be done in a very sustainable way. The ocean produces half of the oxygen we breathe and increasingly absorbs a lot of the carbon dioxide that we emit into the atmosphere from fossil fuel usage. So Cyber Ship Lab, front and center, a key resource that's going to help us keep all future use of the maritime environment cyber secure as we go forward. So thank you very much. And I'd now like to hand back to Chloe.
Thank you, everybody. Really interesting presentations and lots of food for thought. Certainly, if you're anything like me, the technical details take a bit of getting your head around, but it's so interesting and obviously crucially important to the industry. Okay, so our next thing, we're going to have a slight change of pace now. As I said before, we're going to go behind the scenes a little bit and give you a bit of insight into how a project like this actually comes about, and give you a feel for the sort of work, the kind of support and development work that needs to go into a project of this kind behind the scenes. So I think Susan is going to share her screen next, and we'll hear about the work that R&I do. Over to you, Susan.
Thank you very much, Chloe. I'll just share the screen. Hopefully that's showing up okay for everyone. Hello, everyone. Thank you very much to the Cybership team for inviting Jenny and I to talk today about our services and the role in this exciting project. We're from the University of Plymouth's Research and Innovation Department, and I'll provide a quick overview of some of our main services, and Jenny's going to talk in a bit more detail about the support we gave in this particular project. Although our main roles are to support applications from our academics, as this project demonstrates, the main strength of many applications lies in building collaborations with key stakeholders. So we're very happy to work with our external partners to develop research funding applications. So therefore, in addition to the support that Kevin Forshaw and the team gave in this project and other projects in the Faculty of Science and Engineering, feel free to contact both I and Jenny, about this project and about any other research funding applications that you'd like to develop with our academics. So we have two key teams in research and innovation that work on the pre-application stage or pre-award stage of applications. So there's research funding managers. I'm one of those. We've got Dan, Eva and Francesca as well who can support you. And we identify appropriate funding sources, help you to understand the funders' guidance and requirements. As you know, very often it's a matter of translation of the jargon that they use. We review applications and advise on content, structure and format. We can also assist with the internal peer review and approval process. So our researchers will be becoming aware now of the award manager process and sign off from heads of schools and deans, so we can help with that. And we help support you with the funder submission systems. So often they're quite complicated systems, like the joint electronic system used by the research councils and the portal used by the Horizon Europe. Jenny's team, very similar support project development, but also do bid writing and funder liaison. And they'll liaise with external partners a lot more than our team do as well. They can identify sources for traditional and non-traditional funding. So that sort of sums up one of the main differences between our two teams. We support the Research Council funding, charities and things like that. Jenny's team concentrates a lot more on industrial strategy, European structural funds, Innovate UK and those sorts of funding sources. Jenny's team can help develop partnerships, projects with businesses and other organisations, and also help you to understand the funders' requirements and guidance. And just to mention as well, there's Dave Marshall in the team there, who is our knowledge transfer partnership guru. So if you're thinking about employing a graduate on a project that you're working on, Dave would be the person to talk to there. So we help support all academics at all stages of an application, and it doesn't matter how small it is, but we also operate a priority bid process, which is reflected in the work that we did with the Cyber Ship Lab. So there's certain triggers that will implement that process with academics and external partners. So normally they're large applications with a value of to the university of over 1 million. Very often it's because they're complex applications where the university is leading and there's numerous partners, especially international partners, where we have to get letters of support, as Kevin talked about earlier on, supporting that. Very often the complexity is in the partnerships rather than the actual funding itself. If there's unusual or new funding sources, working with US funders, we've done some projects recently with DARPA, and the National Institute for Health, and their funding systems are completely different to ours and a lot more US jargon used in it. If it's a targeted call with high strategic relevance to the university, of course, we'll be happy to support that. If there's a limitation on the number of applications that can be submitted, so very often we have an internal SIFT process where we'll select the project to go forward that really represents the university and has the most strategic value. And also calls where a central organisational lead is required. So Strength in Places Fund is a good example of this, where we're leading on behalf of the Southwest region, really, representing other universities like Exeter, local authorities, and we lead and drive that application forward. So on that basis, with the priority bid process, I'll now hand over to Jenny, who's going to talk about how we applied that on the Cyber Ship Lab.
Thanks, Susan. Could you move it on to the next slide for me, please? Sure. Thanks. So, I mean, as Susan said, our job within the research and innovation funding teams, respectively, is to drive income and research opportunities into the university. And, you know, that's our job. We absolutely appreciate that, you know, for our academic colleagues on the call, you've got multiple competing priorities, you know, teaching, your research, marking, public engagement. So our job is to try and sort of take the heavy lifting away from these application processes. And we'll sort of work through right the way from the horizon scanning bit, you know, spotting the opportunity, through to the project being contracted and live. And as Susan said, you know, we'll offer support for any type of project, but for those larger, more strategically important projects, we'll provide a really sort of detailed wraparound sort of service for you. So how did we help with Cyber Ship Lab? I mean, it's amazing, actually, I think, for Susan and I to hear what the project's doing, because, you know, we only ever see it on paper. So to see it in, you know, reality, and to see that all the things that we hoped it would do, it is doing, is, you know, fantastically rewarding. As was mentioned earlier, Cyber Ship has been funded through the Research England Development Fund. And this was an open call that was launched about 3 years ago. And they were just looking for innovative research projects that would have some kind of unique commercial application. And within R&I, we spotted the opportunity and went out across the university to see what sorts of ideas we could put forward. And there were 3 really strong ideas that came forward through our academic colleagues, one of which was around maritime cybersecurity. Susan and I collated the information, presented it to Research England and said, look, which of these is going to best meet your strategic funding needs? And they came back and they were unequivocal that maritime cyber was definitely the area where there was the most commercial need, demand, and actually a USP for us. So that then gave us the green light to go ahead and develop the application. Susan and I worked very closely with Research England on sort of starting to iterate that process. You know, we set out the broad ideas, and once Research England were happy that the research was strong enough, that we had good links with industrial partners, the outputs were strong enough, and it could be self-sustaining, we could then go ahead and start to properly develop the application. And at that point, we pulled the project management team together. And that had Professor Kevin Jones, Dr. Kimberly Tan, and Kevin Forshaw, plus Susan and myself. And the reason we pulled the project team together is actually to write a successful application, you need to make sure that you've got the strength and depth across all sections of the application. So we have to write a really strong research section. We needed a really strong industrial engagement and financial sustainability section. We still had to do all the stuff around governance, state aid, equality and diversity. So by pulling this team together, we could make sure that we were going to score highly across every step of the application, not just writing something that was really strong in terms of research, but we were going to score highly across the board. And those of you that have been involved in writing and submitting applications, you'll probably all agree that actually the timing of it is critical. And that's again where I think Susan and I were well placed to make sure that we could sort of set up the milestones that we needed to reach to make sure that we're giving ourselves time to get the best possible application submitted. So we would, work with all of our partners around the table and say we would need this particular piece of information in 10 days. We were then able to collate this information, give ourselves time to pull things together in a timely way. So we were then able to have an iterative process with Research England to give ourselves the best possible chance of success. Can you put the next slide up, Susan? Thank you. The drafting of the application is something that we think takes a lot of pressure off of our academic colleagues. We absolutely cannot write the research sections. We've heard Kimberly and Kevin talking, and honestly, the complexity of what they're doing is just completely above and beyond anything we can understand in R&I. But what we can do is we can make sure that we are linking all of the content back consistently with what the funders are going to be appraising us against. I think sometimes there can be a bit of a temptation to sort of run away with the bits that really interest you and maybe forget a little bit about some of the other scoring sections. So, we were able to keep doing that review, refine. And Susan and I were also able to do the drafting for those bits around knowledge exchange, public engagement, governance, state aid. So it was something that our academic colleagues didn't need to worry about. And actually having Kevin Forshaw as part of the project team was absolutely critical when we were both developing and drafting the project, because we had to demonstrate really strong industrial buy-in. And Kevin was, instrumental in providing those links to the industrial partners, getting those letters of support in, which showed that there was real industrial demand out there for what we were looking to do. And even once the application was finally submitted and appraised, again, as we find with lots of applications, sometimes there will be pre-contract conditions, post-contract conditions. And again, Susan and I, within the R&I function department, we took those, we collated those, we made sure we were responding in a timely way. We made sure we really understood what the funders were looking for, so we could absolutely guarantee that we were going to get this project over the line. And it was actually a really smooth process. Research England were fantastic to work with. Both the Kevins and Kimberly provided everything in a really timely way. Susan and I, managed to sort of bring all the information together. We got it funded. We've got this fantastic facility now, which links so well with our other research strengths, as Kevin Forshaw set out earlier, and as Kevin Jones has set out in terms of the sort of the future need of this sort of thing. So yeah, R&I are here to support you, to help you. It's our job to do that. It's what Susan and I do every day, is working with academics on different project ideas. And then once we get the projects over the line, it's then over to you to deliver the project.
Okay, I think we're handing back to Chloe now for the question and answer session.
Yeah.
Yeah, let me just jump in and interrupt before we get to the question and answer session. So hopefully for our audience, we've kind of covered a very holistic view of what's quite a large project. You know, on the one hand, we are doing fundamental and interesting academic research. We're producing award-winning papers. We're looking at fun things like crashing ships, and who can't like that? But also we've got a lot of moving parts. We've got industry partners, we've got government partners, getting from where we were a few years ago, which is this whole sector didn't really exist as a research activity, through to where we are now, was a very strong collaborative effort. And I think there's something about this, as sort of Jenny and Susan just mentioned, being a really good template for the kind of things we actually do quite well at Plymouth. So finding a problem where we have the ability to come up with a novel solution and then bringing all these pieces together to make it work. They forgot to mention they had the job of herding cats at various points in this process. But we did go from, there's a problem, to we are now actively working in a state-of-the-art facility to solve that problem in a very short space of time with enormous effort from lots of people across the university and the sector. So as well as the specifics of what we're doing, I think it's worth remembering this as a model for what we could do in other areas and with other groups. And with that, I'll be quiet and hand back to Chloe for the Q&A.
Thanks, Kevin. Yeah, so we've had some really interesting questions coming in as you guys were speaking. So I'll get straight to them. I think they are mostly, I'm going to have to aim them mostly at you, Kevin Jones and Kimberly, I think. So the rest of the guys might be slightly off the hook, but obviously do feel free to jump in if you can add anything to the answers. The first one that we've got is, do you have an estimate for the cost of cyber attacks to the economy? And could you put a figure on the cost of mitigation maybe over the next 5 years or so?
Let me make a first attempt. It's actually very hard to quantify that because an awful lot of things that potentially have had or might have a cyber element are reported in classical maritime mechanisms as being sort of crew or equipment related. I mean, the only thing we can say is it is clearly in the billions of dollars. I mean, just the attacks we know of, if we just take Maersk and some of the shipping attacks, we're already well over $500 million in the last couple of years. The scale of it in the future, well, closing the Suez Canal for a day was about order 10 billion. So we could see how to cause that to happen. When we're in really sort of paranoid or sort of evil mindsets, depending on how you look at it, closing down Suez, Panama, a couple of other narrow straits for just a few days would result in almost a complete collapse of the world economy. How real is that? Hasn't happened yet. Could it happen? Frighteningly, yes. Are there people in the world with the technology to do that? Yes. Do they have motivation to do it? Probably not at the moment. Cost of mitigation is difficult to categorize in another way. Some of the real problems are mitigated most easily by saying don't do that. And with recent IMO requirements for at least a security risk analysis as part of sort of standard operations, some of that will be covered. There's at the moment a lot of wasted money in the sector, to be quite honest. People are buying services and kit that don't actually help. It's very typical of kind of a nascent industry. Cyber protection in the maritime space is nascent. The end part of the question, which was, are we spending enough? Are we doing enough? Probably not, but it's ramping up. Part of what we're trying to do is raise awareness. Part of what we're trying to do is provide cost-effective solutions. We're not alone in that. Industry is gradually coming together. So I think we'll see this develop, and I think we'll do better going forward. Don't know if you want to add anything, Kimberly?
Yeah, I'll add two things. So I think the cost of an attack is an interesting question because one of the things we're doing with, say, the rudder scenario is we're looking at compromising at different points in time or different geographical locations. So doing that in the middle of the ocean is probably very low cyber attack cost because someone will have time to detect it. they can then manually override it and steer it with, they just literally slot in a big wheel and steer it by, mechanisms alone. Whereas the thing we're looking at with the Valentia port, if there's very little time to react and the ship is able to block the entrance to the port, then that has a port outcome. So it's the same attack in 3 different ways, but the econometric effect is vastly different. And the other thing with mitigation, one of the reasons why we wanted to do this now, while there's more technology, autonomous and green energy kind of technology coming in, is that if we can put in a little bit of money now to make sure that things are secure by design, it'll cost less in the future to try and fix issues that have been ingrained in new systems for 5-6 years. So it will probably be costly no matter when we do it, but the hope is that if doing some research now could kind of lessen those costs, and also we can be smarter about where we put our money. So as Kevin mentioned, sometimes it's just training, and sometimes is we actually need to build a new box. So being able to make the right decision first and not kind of go through 7 firewalls and try, 10 different training that wasn't really the right one. Hopefully we can help make those, give the information to make those right decisions early on, so less effort and money is also wasted. I think that's kind of all I want to jump in with.
That's great, thank you both. Another interesting question, which Kevin touched on, but which this takes slightly further, and interestingly, it has come up in recent conversations for us, so this is a really good one. Do we come up against issues with the sensitivity of the vulnerabilities that we discover during our work? For example, a large container ship operator, or indeed the Navy, might be keen that cyber vulnerabilities that they are suffering or that they know of are very closely guarded. How do we approach that kind of thing?
It's a very common problem in the cyber sector. I often use the analogy of the banking sector, which 10, 15 years ago now was very much in lockdown mode and trying not to tell anybody what was going on and hide as much as they could. What eventually came out was it was actually easier and more efficient to share within a circle of trust what's really going on. That allows everybody to be mutually supportive. We're beginning to move in that direction in the maritime sector. We've got a long way to go. I think we need mechanisms, and I don't mean sort of technology, I mean sort of policies and agreements and so on, that allow the industry to be open in the right way. One of the things I'll give tremendous credit to Maersk to, when they were hit badly by sort of the NotPetya attack a while ago, they actually were very open about what had happened, why it had happened, and basically how they'd ensured it couldn't happen again. I think it's that kind of mindset that will allow the sector to move forward a little bit. But it's not only just hiding, it's also lack of awareness. I mean, there are a number of cases that we've sort of looked at in periphery where it is possible there was a cyber element involved in what happened, but that wasn't visible to the people reporting what's going on. So for example, if somebody were to hack a system in such a way that it just went off, it would be reported as equipment failure. So there's a lot of maturing to do in the way the sector deals with cyber incidents, cyber threat analysis. So there's a fair way to go on that. But I think, again, we are beginning to see people move in that direction.
And another one that's come in, which sort of again builds on this point, is what can we do, or what are we doing within the project to promote industrial stakeholders to publish data about cyber threats and attacks that they have faced?
Certainly everybody we talk to, we sort of give the spiel that I just gave, which is the more sharing there is and the more commonality there is, the better off we all are. One of the things I think we can offer as an academic organization is we're not competitors with anyone. So as we build trust and relationships across the sector, the right anonymizing and sort of sanitizing of data for sharing is something we're actually in a good position to do. So between ourselves, class societies, regulatory bodies, there's sort of the possibility of creating an environment where that kind of data can be shared in a meaningful way. And again, sort of following the example of the banking sector, as people realize the benefit to them in sharing, including their dirty laundry, the more I think we'll see that starting to happen.
Another interesting point that's been raised here is how do we intend to go about publishing our research findings so that we don't provide a kind of how-to training set of materials for any less ethical operators that might be out there?
So that's a classic question for anybody engaged in any kind of cyber research. And sort of my short answer will be carefully. Kimberly, do you want to give a longer answer?
Sure. So we're more than happy to work with, especially with donated kit, but also if we've bought something off of eBay. If we find something dramatically bad or even a little bad, we're more than happy to talk to the manufacturer and make sure that there's a patch or a solution in place before we publish anything about the vulnerabilities. In the case where that's not possible, we are able to kind of anonymize the specifics enough that we can tell the story and provide the specifics needed to, you know, the reviewers or somebody if they needed to know, but keep the kind of critical details and how to hack a ship out of the papers. But we prefer the first way because then there's a solution out there. But there are kind of ways to publish kind of, you know, public things with anonymization and things like that.
Absolutely. It's certainly an issue of which we are very aware, and the team is, you know, we're very careful about how we do publish this information, certainly. A different type of question now, again, though, I think for Kevin and Kimberly. Can you further explain how you differentiate yourselves from external pen testers that companies bring in to identify vulnerabilities in your IT and OT systems?
Yeah, a couple of ways, actually. The first one is we are very focused on this sector. There are a lot of very good pen testers out in the world. Many of them are focused more on sort of IT-like systems. We know of a case where one particular shipping operator paid a large amount of money to get a vulnerability assessment, and they got a 100-page document out of it, which was useless to them because they didn't actually know what to look at. The way we'd approach that would be very much more sort of sector and risk specific to try and give something meaningful. The other thing I'd say is because of the facilities we have in the ship lab, we can do things that no one would let us do on board their vessel. In fact, I mean, we found some situations where we can physically damage hardware with a cyber attack. Those are the kind of things you can do in a lab you couldn't do in situ. You couldn't do in simulation because the physical hardware doesn't exist to do that. I mean, there are some examples, not particularly in this scenario, but in others, where you can melt down parts of a motherboard. That melting down has a very physical consequence that you couldn't see by just looking at a simulated environment, but also you wouldn't want to see on board a real vessel in operational states. If we get our lab sort of to the point where we intend to get it, the results we get should be indistinguishable from what you'd get in situ, but it's done in a much more controlled environment where, for example, we could genuinely build and then release a very nasty piece of malware specific to sort of that bridge setup. And we could do, we could do it in an environment where we can control that, which means we can actually do it. I doubt very much whether shipboard operators would allow us to release that in the wild. And if they did, well, we can all see the problems with that. So it's quite a different mindset and a different perspective. There are circumstances where we would go out into the field, but to us, that's a sort of addition to what we can do in the lab and do with our tools. So there's some overlap between classic pen testing and audit firms, but it's not really quite the same. What we can imagine happening actually is some of the very good pen testing firms wanting to send some of their people down to our lab to work on what they're able to do in an environment where they can do it. So in that sense, we don't see us themselves as being in competition. We see it as a collaborative environment where they could perhaps provide some expertise, and we can provide an environment where that expertise can be tailored to the sector. So, you know, again, looking for ways that everyone wins here, we want to be a facility for enabling that.
Yeah, and a couple more things to mention about the facility. So we do have a number of panic buttons throughout the lab specifically for this. We can stop an attack in its track. So there's also not the potential issue of an attack on a real ship somewhere accidentally shuts down the whole fleet, which would be very embarrassing. The other aspect I think Kevin kind of touched on with the ability to configure our ship. We've had a number of partners basically say, yeah, come over and visit our ship. But it's very difficult even for the technicians and things to get to a port in time for the ship coming in and get a 10-hour window to do everything they need to do, because these ships have a schedule and money needs to be made and all that. But with the lab, we could leisurely, whenever we want to, set it up to this ship, then say, actually make it 10 years older, swap these few systems out, and then do a test on that. Or then say, yeah, that's been nice, but now let's look at an oil tanker. So the speed at which we can also do tests and the safety in which we can do tests, I think that kind of sets the facility apart as well.
Yeah, absolutely. Okay, different type of question now. I'm going to give you two options which have come in, and you need to advise us which one of the options you think needs more focus. So you've got targeted attacks on systems and equipment on board a ship, and attacks on shore-based networks and systems that eventually lead into ships. Which of those do you think needs more focus?
From my perspective, the answer is a bit of both. But if you have to pick, it's A, because most of the shore-based networks and systems tend towards more conventional IT, which means there are an awful lot of people working on it. There are already solutions out there. So it's less, it's a more well-developed field, so there's less obvious vulnerability. Now, of course, you can't really distinguish between those two, because ultimately we're looking at a large-scale system, which is ships and ports and ecostructure and everything else. But what we are specifically able to do that's harder to do anywhere else are the ship-based systems. And in some of our scenarios, we deliberately use a ship as a vector for bringing an infection into a port, because the port systems are conventional IT hardened and so less easy to get through.
Anything to add there, Kimberly?
No, I think that pretty much sums it up. I'd agree. I think that ports are important, but because of that, a lot of people are focused on that. And the number of people we've talked to where they say, we have security up until the point where the people or the cargo goes onto a ship, made us a little concerned about that kind of part of the supply chain. So that's where we're focusing our efforts now. Of course, if the research goes really well and everything balances out, we can look at things more evenly. But for the Cyber Ship Lab, we were definitely interested as a potential weak link in the entire chain.
Just thinking about ports then, because they've sort of come up in conversation, and particularly smart ports. The questions come in here that says, is it smart to innovate ourselves further when the end result may be that there won't be people around then with the skills to manually operate the supply chains if things do go wrong? How are we addressing that?
I think we should let you and Kevin Forshaw answer that one.
Kevin F., do you want to pitch in?
Yeah, that's a great question. That is a great question. And, as with all great questions, I'm not sure there's a very easy answer to that. The bit I do want to bring in, if I can make this video thing work, there we are. The bit I do want to bring in is obviously Plymouth now has free port status. And one of the areas, so we as a university are leading on innovation and clustering to support the free port going forward. And a big focus for the research effort in that is going to be around the future of smart ports. So how can we embrace the efficiencies that smart ports are going to bring without compromising security? And Chloe on the call, Chloe's been doing lots of work with various agencies, all concerned about this issue going forward. So trying to answer the question and not being a sort of politician in terms of avoiding the question. Yeah, it's a good one. For me, it's only if we can determine that those systems that are developed for smart ports are sufficiently secure with appropriate redundancy in place, so that if key aspects of that fail, we do have a plan B to sort of back up those systems, then that's when we should adopt smart ports more universally. Now, in the UK, the smart port environments we're going to need are going to be very different to what they would have in Rotterdam, for example. Now, Rotterdam is increasingly in a very sophisticated smart port. But yeah, I'm probably going to leave it there because I'm not answering it well, but I think they should be sufficiently robust before we do embrace them fully and have redundancy, so that if certain aspects fail, there are ways of doing it manually or doing it in an alternative way.
Yeah, absolutely. And the other piece of the jigsaw is, of course, training. And that's something that we're looking at as part of this whole project. The idea that obviously cyber attacks are here to stay. That's the reality. They're not going to go away. We can't stop them, but we can prepare people to deal with them in the best way possible. And obviously a big part of that is ensuring that everybody who is operating any of these systems is in the best position to be able to recognize a cyber attack for a start, and then to know what to do about it in certain scenarios. So the whole idea of training to mitigate cyber attacks is something that we're looking very closely at as part of this.
I think another thing that might be worth mentioning, the way the question is specifically asked is, we're kind of infantilizing people by taking away certain capabilities. But I think if we do it right, we should actually be enabling people. So automation is good for what we classically call dull, dirty, and dangerous. Those are the things we don't really want people doing. We want people doing the things that they are really good at. We want systems doing things that systems can do in a way that enhances what people do. So it might mean retraining, it might mean people doing different things to what they do in ports now. But I think we're a long way, if ever, from a position where we don't need people in the loop. We just need them in the loop at the right place, where sort of human skill sets actually pay off, not sort of everywhere. So I think it'll be change rather than replacement. And yeah, numbers of people might change. We've seen the same in every industry where automation comes in, but ultimately you should get more well-paying jobs and less poor-paying jobs if you get it all right. And that's a big if, of course, and that's somebody else's problem.
Okay, so I've got one more question, which is an interesting one, very broad. Anybody feel free to pitch in here. And it goes, is there an argument for, and would it be practical, to simply unplug ships from the network? Can we get this genie back in the bottle effectively?
Yeah.
I'll jump in first. I think that'd be very difficult, and a lot of the technology we have is not just for technology's sake. I mean, a lot of the newer electronic systems, newer in quotes, came out of incidences like the Titanic and stuff. So safety is a big reason why we've introduced all these things. Another example is like not just navigation, but even things like mooring, to get a ship to dock and stuff. Doing that with ropes was dangerous, and we have automatic mooring systems to kind of protect lives and physical health. I was reading what are mariners interested in for a job in this sector, because there's a decreasing number of kind of mariners, and below reliable payment was kind of internet connectivity, because people want to be able to be in touch with their loved ones and have Netflix and all these other things, kind of to remove that isolation. And then with things like green, the need to be lower emissions, I don't think we can reach the level of emissions we want to with kind of human skill alone. I think we need the systems to be alive and monitoring 24/7 and making those micro decisions. So there's just too much we need the technology for in terms of green technology, safety, physical and mental, and also just plain efficiency, that I don't think we put it back in the bottle. And I think we just kind of have to make sure that we can make these things safe and make life better without adding more of these vulnerabilities.
I think just to add a little bit to that, sometimes there's also the assumption you can only be hacked if you have an active network connection, which is of course completely untrue. Some of our more malicious scenarios take months to lay the groundwork for. They actually happen months away in a port a long time before the incident happens, and then they are triggered by a certain set of events. So even if you did isolate the ships when actually underway, it wouldn't help. It just means we'd have to find different vectors in. Some of the most significant vectors are people-based. So actually, no, unless you're prepared to go back to kind of the age of sail and all the implications therein, you really need the technology. And if the technology exists, it can be compromised. So no, it isn't as simple as kind of putting the genie back in the bottle, unfortunately, or fortunately, depending on your perspective, I suppose.
Well, it sounds as though perhaps we wouldn't want to put the genie in the bottle anyway. Here's an interesting question, which I haven't encountered before. You guys might have done, but this is a great one. What cyber threat is keeping you awake at night?
Okay, my answer is nothing keeps me awake at night, regardless of what it is. But a bit more sort of on topic. The thing I think that is most worrying to us, having looked at this, there are a number of very big players that could potentially be interested in the maritime sector from a cyber point of view. Nation states, organized crime, major terrorist organizations. If you look at what they could do in any scenario, it is actually quite scary. I mean, from one point of view, causing World War III deliberately by making it look like one nation is an aggressor crossing into territorial waters. Bit dramatic, technically possible. More seriously, the kind of horror scenario I hinted at earlier, closing down various shipping lanes for a day, a week, a month. We have some attacks we've looked at which have closed down ports for months. And it would be very difficult to mitigate those in any reasonable way. What's the hope that keeps me coming into the office in the morning? And that's that if we can get ahead of this curve and properly understand the vulnerabilities, properly understand the mitigations, and take action now, then some of the worst case scenarios can be avoided completely. And I think that's sort of, looking at it from a positive point of view, optimists think the glass is half full, pessimists think the glass is half empty. I'm an engineer, so I think the glass was designed to be twice as large as it needed to be. So we're kind of going to look at how can we actually solve the real problems in a way that helps make sure we don't have to stay awake at night.
Kimberly, how's your sleep?
Well, I was about to say, the first thing that popped into mind wasn't maritime related. It was, I can't let the chocolate factories go down because, that would just be, chocolate and cake. I just can't do that. Some of the things, one of our events, we had Lord of Earthnot do a keynote, I think it was. And when we were talking to him about, how much energy is produced locally and how much, oil or fuel comes across on ships and pipelines. And, being able to cut it off at the kind of ship supply chain level. A lot of infrastructure doesn't do well off. It's not just turn it off and then turn it back on later. It could actually, get damaged by being not running. So it's just not a matter of bringing more fuel again a little bit later. So, water, power, all these things. It is kind of scary how much can just kind of cascade fail from one or two things missing. And that's a little terrifying. So
on that scary nightmare note, then let's wrap things up and hope that none of this stuff ever happens, because of course we will use our research to mitigate against these events. I guess it just remains for me to say thank you very much to everybody, the panelists who've given such brilliant presentations, but also the listeners who were interested enough to tune in today. should you wish to get in contact with us, I think in a second there'll be a slide that's shared with our contact details on, and if not, just Google Cybership Lab, and my contact details are certainly on the website. Feel free to email me if you've got any inquiries or questions. Great, thank you very much, everybody.
Thank you, it's great.